And this is part of the reason why I wanted us to do these operators, is that I wanted us to understand that when we are doing operator overloading, we are essentially what we should be, I think, at least in my view. And you aren't bound to this in C++, I don't think at all. I think you can implement these operators however you want, but my strong conviction is if you implement the less than operator, you should really strive to implement it like the less than operator should be implemented. You shouldn't implement less than to be greater than or something that it isn't um, in its purest mathematical sense. And the reason for that is I think it's going to confuse people. But on top of that, if you don't have the semantics match what the mathematical intuition is, you may also be limiting machine programming systems from being able to learn from this code. And the reason for that is there is a precise definition of what it means for something to be less than something else, or greater than, or not equal to, or equal to. And therefore, if you have operators for classes that precisely explain what these operators are, you are actually telling the machine programming systems essentially what the semantics are for these operators. Like you're actually teaching it, or you could teach it depending on how smart the machine programming system is, how to learn what those operators are for this type. And on top of that, the system could potentially, if it's smart enough, try to start to generalize that, especially if it starts to see enough good examples. How is this helpful? Well, if the system understands the semantics of the code and it can reason about that by code analysis, then in cases when your code doesn't use those semantics the way they're defined properly, it could potentially identify those as bugs.